Okay, this is a good time to start. Welcome to the January meetup of the Jersey City Java user group, January user group. Variable interpolation in my head was difficult. And so, Happy New Year. It's a weird year already, but we're doing our best, right? I'm coming to you not from Jersey City, although normally I do live in the New York metro area. A few of us on this call do, which is great. That gives us some legitimacy. Um, but I'm happy to revive this group. I heard that it became kind of unmaintained about a year ago, and a fellow New York Agile consultant pointed me at it and said, "This looks like your kind of thing. You should run this group." So I did, and I'm really happy that we've had excellent speakers. And in just a moment, I will introduce today's. Um, you may see or you may not see, but I'm telling you now, this is being recorded, and we will post it to YouTube afterward. So if you don't want to be in that video with your face and with your voice, this is a great time to turn off your camera and mute yourself and make sure that you ask questions only in the chat, because otherwise you're relying on my skills as a video editor, and I don't recommend that you do that. I could, but it might not be good. So please mute yourself and mute your face, as we say, if you don't want it to be in the video. Otherwise, welcome. I just made coffee, but I wish I could share it with you, but I can't. We will have a meetup next month as usual. I'll announce that a bit later. But for today, I'm very excited about this. I'm going to try to say your name, and I think I'm going to try to get it right, and you're going to give me a thumbs up or thumbs down or acceptance test. Emily Bache. Yes.
Good one.
Okay. Sweet. I have a difficult name, so I'm very attuned to making sure that I get other people's names correct. Emily Bache is here. She's a technical agile coach. She works with teams in their code. And you may know her from Pluralsight or from 2 essays in 97 Things Every Programmer Should Know, or from her book, The Coding Dojo Handbook, or from a new book that I think we're likely to hear about today, and a very new book. And I'm not only pleased that you all will get to see her in action today, I'm pleased that I will, because even though we have a lot of values and coaching approaches in common, and even some shared experiences with places that we've worked, we have not yet met until now. And so I'm really excited to learn from her today. So without any further ado, that was enough. Please welcome Emily Bache, and I hand it over to you, Emily.
Thank you. Thank you so much for that introduction. So this is exciting. I have spoken at meetups in the past, but never really quite like this. So I'm sure this is going to be fun. The meeting, I've kind of got a vague structure for it. And I think the first thing I want you to do is to do the warm-up. So I've got a Miro board, and I just posted a link to it in the chat. And I'm hoping that everyone can follow the link and go to the page. And it's kind of laid out left to right. So on the far left, there's a board with just some like pretty icons in.
I did not.
Oh, is it not letting you in? I can see some people have got in. I can see about 20 people are in on the board now, so that's a good start. And at the far left, there's a frame called warm up, and to the left of that, there's lots of icons that you can copy. Or if you know Miro, you can find your own icons if you like. But I want you to warm up. How do you know when you've written enough tests to refactor safely? Put a symbol next to any notes you agree with and add any notes you feel are missing. And I'm just going to give you a few minutes to come up with something. And I can see that some people are in there already starting to do stuff. Oh dear, somebody's moving the frame. I need to lock that. Generally. Oh, this is great. Some new notes appearing as well. Okay, I'll just give you a couple more minutes. I can see that some people are still writing stuff there. Cool. So I think most people have had time to read the notes, and lots of people making a mark next to the note that says, when I feel confident that my test will catch my refactoring mistakes. So that's interesting, that there's a lot of people here who are who think that confidence in your tests is an important way to think about them. And there's a lot of icons around the new note, which I didn't write, which is when the tests represent all of my current expectations of the code. So it's about expectations as well, that you have expectations on what should work and that you need to encode that in tests. So that's cool. And then some other notes around getting a few icons as well. So mostly the point of this was just to get you to start thinking about, well, we've got legacy code. How do we know we've got enough tests? What is that about? Confidence, expectations seem to be coming up here. So I'm going to share my screen and talk a little bit about this. We'll see if this works. So I'm hoping you can, yep, I'm getting nods from Amitai, so that's good. And I can still all see you on that screen. Good. So legacy code. This is a meetup about legacy code actually, and I kind of think of legacy code like this: that it's valuable code that works. Developers find it difficult to work with, but we need to change it. We need to change it safely. And I've got this picture here of this chest of drawers, which is kind of like a metaphor in my head for how I think about legacy code. It's this really, really useful piece of furniture that I've got in my house, and it's been there forever. I rely on it. There's stuff in it I need, but I'm not entirely sure of everything that's in those drawers. I don't quite have complete control over the contents. And some of it might be a bit messy. So the thing with legacy code is we need to change it, but it may not have any tests, and it may not have any testable units either. That's usually a feature of code that doesn't have unit tests, that the units are not as small and well defined as we'd like. So it's a bit of a catch-22. We'd like to have tests, we'd like to have units, and you can't get the tests until you've got the units. You can't refactor to create the units until you've got the tests. So that's one of the reasons it's difficult to feel confident to change legacy code. So this is where I think that the metaphor with the chest of drawers, what I want to do is I want to find some kind of unit. And it's like I want to pull out a drawer, just one drawer from that chest of drawers. And that's going to be a considerably larger piece of code probably than I would normally, if I was doing TDD from scratch, those units would be much smaller. So the unit that I can pull out of a piece of legacy code might be a bit larger, have more behaviors, but it might be easier to pull out a piece that size than lots and lots of smaller units. So I'm going to pull out a drawer, then I'm going to go through everything that's in it. I'm going to cover it with tests. And this is where we were talking about that thing with confidence. How confident I'm covering all the important behaviors. all my expectations about the code, are they covered in tests? And we're going to have to probably find some suitable test data to execute that code, and we're going to have to evaluate the results we're seeing and work out if we think they're okay. So I kind of, with a chest of drawers, this is like going through all the socks that are in there and working out what we've got. And then the next step, of course, of the legacy code is to refactor it, improve the design and make it easy to add whatever new functionality it is that we need to add. So we're going to get our socks in order to make it really easy to see where to put the new sock. That's kind of the analogy. So that's the general idea. And then, of course, when you've got that drawer sorted out and refactored, and then you can take the next drawer until you've got an entirely well-factored chest of drawers. So this is the kind of general approach. You first find seams and pull out that unit, isolate it from the rest of the code so you can test it separately, cover it with tests, and then refactor and add the new functionality. So the part that I'm really focused on today is this part where we cover it with tests. And so I want to make it clear that I know that there is more to legacy code and this kind of thing than just this step, but this is the part we're looking at today. And we're going to be using approval testing. And the thing with this is we can assume the code works. It's legacy code, people are using it. So we're just going to approve whatever it does. And I'll show you what I mean by that very shortly. And then we can use code coverage to help us to work out what more behaviors we need to cover with cases before we'd be confident to refactor. So that's the initial intro. And then I've got this code for us to look at. So here I've got an IDE, and this is the code that I wrote about in the message to you. It's on my GitHub. If you want to have a go at the exercise, you'll need to download it and get it. It's a starting position on the master branch here that we're looking at, and I've just loaded it in my IDE. Please tell me if the code is too small to read, but hopefully it's okay. I'm getting some thumbs up, so that's good. And as you can see, there are no tests here, or at least this test doesn't do anything. But we've got some code that we want to get under test, and that's this class, XML exporter. And you know, the first step was to pull out those drawers. This code, I've designed it specifically so that part is already done, really. We've got static methods here, which are like drawers that are already pulled out. It's got no dependencies apart from the input data, and all the results are included in the result, which is a string. And we've got 4 static methods in here. Just collapse them so you can see them all. So I've got 4 static methods, each of them, there are public static methods and a private one, but we're not going to worry about that so much. So these 3 will take a collection of orders, this one needs a store, and they all return a string. So we're going to start by writing a test for this one. So if I can just call it. That's a good start. I need some orders though. And at this point you're thinking, oh, okay, if this was real legacy code, you'd probably be able to go to some database somewhere and you'd probably be able to find some orders that were vaguely representative, and perhaps talk to some customers or testers and find some good test data. So this is an exercise where you don't have that luxury, but I found some test data for you already. So you've got some test data, and this class is in the test folder. It's called sample model objects, and there's a bunch of products. There's a store, some more products, and then there's an order. So just the one order here. But I can use that here. I need some orders. So let's have a local collection of orders. I think I can do list of my recent order, import from my sample model objects. I can import list. And does that not work? What did I do wrong? Set language level to 9. Okay. There we go. And here I should change this to something better than that name. Okay, so that's a start. You know, I've got something that's going to call my method, but that is not really a very good test yet. I'm kind of missing the whole asserting the result part of the test. I've got my arrange and my act, but I need my assert. So here's where I'm going to use the approvals thing. So this thing returned a string. If you remember, it was some XML. So what I'm going to do is going to use approvals dot verify XML, which is the approval testing part. So before I really explain what that does, let me just run this test and show you what it does. So it's just compiling some stuff, and the test has failed. That's good. And it has produced a diff tool for me. So I'm hoping that it will do that on your machine as well when you do this. It's kind of the default behavior of approvals. So approvals testing, the normal behavior is the test fails the first time, because what it does is it shows you what it got, what was passed to the approvals.verify XML, this XML that it got. It's showing you here. That's what I got in this received file. And it's showing me that doesn't match the approved file, which is completely empty because we've never approved anything before. So here you can see that these two files actually exist in the same folder as the test case. So what it's done by bringing up this diff tool is it's asking me to make a decision. Is this output here good enough to approve? And if you remember, this was legacy code. Whatever it does is correct. It's in production, people are using it, so I can feel fairly confident just approve this. It looks kind of reasonable. It's XML at least. And there we are. So now I've approved that, which means I copied the contents of the received file into the approved file. And then the next time I run it, it passes. And that's because, of course, it received the same text as last time. It compared it with the approved file. They were identical. So it marked the test as passing. So now I've got a test, which is a lot better than I did before. So I'm going to run my test with coverage. Now I mentioned this thing about coverage, trying to use it to help me to work out what I still need to cover. So I've already configured my coverage tool a little bit. But I'll show you here. What I like to look at is the green markings in the gutter. This number, it says, 40% of methods and 25% of lines. It's kind of okay, but I'm really interested in which lines, because I was calling the export full method, and I can see I'm actually covering quite a lot of the lines here, which is a good start. But I'm not covering these lines here. It seems I need a product with a weight of greater than 0 in order to cover those lines. So I'm not done yet. I'd probably like to add a little more code so that I can cover those lines. And then, of course, I've got these other methods that I'd like to cover. So rather than me standing here and doing a demo for you, I want you to have a play with this and try it out for yourself. And I want your goal is 100% coverage of the XML exporter. And I was hoping we could use breakout rooms. I don't know, Amitai, are you, I think you're in charge of the Zoom. Do we have access to that?
I don't rightly know, but let me make you a host and see if that can help.
Okay. And in the meantime, I'm just, in case anyone hasn't got the link to the GitHub, this is the code to play with. And hopefully you'll be able to make a start there. And by the way, you can do, I've got that sample test data, that sample model objects. You can do anything you like with that. Now, I'm not getting breakout rooms.
Where would you see it if you had it?
At the bottom of the screen.
Okay. Yeah, I have a paid account, but maybe not a sufficiently paid account.
Oh, you probably, when you
No,
create the meeting, you have to put it in the
Is that how?
settings.
Oh,
you probably can turn it on mid-meeting in the settings.
let's see.
When you log into the Zoom website and that kind of thing. Otherwise, everyone will be working on their own, which is just less exciting than I thought. If I put you in breakout rooms, you could, you know, talk to one another and fiddle with the code together. I should have warned you about that, Amatai, sorry.
Looking.
You're looking. So yeah, it's, if anyone knows how to do this.
I've done it, but I don't know how to direct you remotely to turn on the feature, enable the feature.
I found some help text.
Okay.
I suppose Amital, you're right, your name is hard to remember. Is it something that you set on the Zoom webpage when you're...
Oh, do we have to restart the Zoom session for it to work?
No, I doubt it.
Mm.
I doubt it, but
yeah, because
I
it's in
always
the web.
just get that little, I always just get that little icon at the bottom of the...
It does look like you have to do it in the account settings, though.
Yeah, yeah. You can't do it from the meeting.
I don't know if that means that you have to reset the meeting or not, but it means go to the Zoom website and check your settings there.
Okay. If we have to go that far, do we want to restart the Zoom? Will people be able to rejoin quickly? Is that all right?
Can you keep the same ID?
I think so.
Okay.
Just a moment. I'm going to find those settings.
So while you're doing that, maybe
Wonderful.
I'll run some, I'm gonna say I don't want to put you on the spot completely. So I'm going to run some little slides here, which I was planning to run later anyway. So I'll rather than, let me talk about code coverage a little bit. So I'm sure many of you already know this stuff, but I thought it would be useful to just have a little bit of theory about code coverage. So when you're running your code, these gray boxes are like statements. And as you the flow of execution goes through and executes those statements, those, you can think of those have been covered. And when the flow of execution stops, then all the statements that came after that point didn't get covered. They didn't get executed. So when you're running your tests, some of the statements may have been executed and some not. And that's what we talk about when we talk about like statement coverage. And the percent of statements that are covered is your coverage percentage, things like that. So what it means for the testing side of things is those statements that we actually executed when we ran the tests, they have some possibility to then affect the test results because they actually did execute. Whereas the ones we didn't execute, well, they cannot affect those test results. That's really what all it means. It doesn't mean that those statements actually are bug-free or not. We don't actually know that for certain. We just know that they were executed or not executed. And then, of course, program execution is not normally completely linear like that. Normally there are branching points where there's some kind of conditional where it's going to make a decision about which branch of code statements to follow. So when it comes to coverage of branches like this, the green ones, we can still see those definitely got executed and the red ones definitely didn't. But the actual conditional itself, the if statement, is said to have partial coverage if we've only been down one branch of the if. And that may seem like a bit of an academic difference when you've got both branches here. You can see the red and the green anyway. But if there wasn't an else in your if statement, then the only clue you'd have would be the yellow if statement there, that there might be something that you could cover better. So that's why you might want to enable branch coverage, because it gives you a little bit more information. And then, of course, what we're generally doing with legacy code, there might be a lot of code branches, a lot of if statements. And in order to actually execute all of the statements, we probably need to add more than one example or more than one bit of test data. And that will enable us to test more code branches. And then if you've managed to, as I was encouraging you to do with this problem, to get 100% coverage, that doesn't guarantee your tests are perfect, but it does mean that at least you've executed all your statements, which is a good start. Those statements that you haven't covered though, they may be unreachable, and particularly in legacy code that can happen quite often, that this code is actually dead. It could be boilerplate code that somehow just can't be covered because it's just, yeah, some kind of definition, or it may just be not important to cover and you might be better spending your effort elsewhere. So don't get too stressed if you do have some uncovered code. On the other hand, of course, if it is covered, that doesn't mean it's actually guaranteed to be working, even if you've tested it. Because one fundamental thing with code coverage, it can't show you the code that you never wrote in the first place. The classic case is the catch statements for exceptions. It can't tell you that you're missing one. And then with the branch coverage, as I mentioned, it gives you a little more information, but it also takes longer to calculate, and you may not need it. So it might be overkill. Well, it's up to you, really. So I think that's what I want. Oh yes. So the way I would use coverage. This is my last slide on coverage. Find the code that should have tests, lean on it to add tests while you're trying to get coverage in order to refactor. And you can also look at the percentage over time and see whether your trends are going in the right direction. With legacy code, that can be kind of encouraging. You can see progress, and that can be helpful. So I'm just going to go back to IntelliJ. How are you doing, Amitai?
I think it's enabled. So if we're ready, I can end the session and restart it.
Okay, and it'll be the same link.
Yes.
Great.
Fingers crossed.
If not, you'll tell us on Meetup, I'm sure.
I guess so, but let's have it be the same link. That's what I'm going to say. Yeah.
See you all again in a moment.
Okay.
Welcome back, people. So welcome back. I think there's still a few people in their breakout rooms who are just coming in, but the Miro board had another frame in the middle called conclusions, and it says, explain in your own words how to use coverage and approvals to get legacy code tested. What are the steps? So this is a chance for you to just reflect on what you just did. And I'm going to have to say that again because now just like loads of people just joined back to the main session. Welcome back, everybody. So there was a squeaking noise. Is that me? I think that's
Let
me.
me recommend that
It
everyone
is.
who isn't Emily, please mute.
Sorry, it was me. I set myself a timer that I forgot about. Okay, so let's go to Miro. And there's a conclusions frame for you to reflect on what just happened and write something about what you've learned. It's very important to reflect when you've done an exercise and to think about it. So please write something on a sticky and put it in the Miro board.
Yeah, could you post it again, maybe? The Miro board, because of the...
Sure.
Would be great, thanks.
Is it properly pronounced Miro? That would be really cool because then it doesn't sound anything like Mural.
I have no idea, but it makes sense to me.
I don't know either, but I'm going to start calling it Miro just for that very reason.
Emily calls it that, so it must be correct, right?
I always assumed that it was based on the romance of the Spanish, I guess. I look where I see.
Great, so lots of people are writing a little sticky note. This is good. It helps you to remember stuff if you write it down like this.
Emily, could you share your screen as well? I'm just joined from my cell phone and not able to participate in Miro. Thanks.
Yeah, so a few people still writing stuff. Yeah. Scrubbing the date. Yep. That one's really succinct. I like that one. Call the code, verify the result, look at the coverage, add more if needed. Yep. Garbage in, garbage out. Yeah. You got to think. Pinning test. That's interesting. I don't actually have heard that before.
I use it as a term of like you're pinning the current logic so that you can see when you've changed something.
Yeah, like a characterization test, but pinning. Yeah, I like the metaphor of, you know, pinning it down. I might be able to get away with fewer tests than I expected. Ooh. That's I thought that it probably meant you needed, maybe it was easier to write them, but I think you still need quite a few tests to feel confidence.
We only needed one per method.
Yeah, so there were different ways of tackling that. Some people created a new test immediately they were needed to change the test date, and some people just modified the test data and reused the same test. My preference is for the former, but I mean, both work.
We did a lot of let's inline this variable so we can see how it's constructed to see what we need to change or add from the sample data.
Right. Just to yeah, because you didn't create the test data, I did. So just to understand it, that would probably help. Yeah. Cool. Much better approach than manual testing. Yes. Oh, yes. There's a really small one over there. Easy to start, does not need much knowledge about the code to start. Yeah. Writing the first test is always the hardest one, actually. Good. So thank you all for your notes. This is really useful. So I wanted to show you a solution to this. I mean, you've done, I've been around your groups and you've all made progress on this problem, but there's another branch. So I'm checking out the branch with tests. And this is basically my my best effort at a sample solution. So if you've got a clone, you can just switch branch to with tests, and you can see this. So like Llewellyn said, I've just got one test per function actually, and I'm just adding making more test data so that I can cover all the branches. So I've added this old order because for some of the branches you needed something that was a little older, and it uses a different product, the one that has a weight. So that kind of covered the branches. So so I would do it like this. I think you can do it with creating more than one test for each method. That works as well. You get more tests, but you don't get more coverage. As far as test maintenance is concerned, having more tests can be a disadvantage because then you have to examine more failure results, or it can be an advantage because they don't all they're more specific and they're more targeted. So which you choose depends on your situation. It's a judgment call. The export history, now I'm not sure everyone got to this, but some people did, I'm sure. You discover that it prints out the current date and time. And that means that every minute you have to, the test starts failing again. So you have to do something about that. You don't want your test to fail because these details change. So there are several ways to fix this. And one that I saw people doing was you go and add an argument to the export history that takes an argument which is the current time, and it uses that, and then the test can control it. That's the dependency injection approach. It's the same approach you'd use in any normal assertion-based testing way of doing things, and that works too. But here I'm choosing to show you the scrubber. So you pass this extra argument to the verify XML, you give it a scrubber, and I've just got a regex scrubber here that's going to pick out this pattern and replace it with this fixed string. So if I look at the export history, it's just hidden behind my thing. You see it's replaced it with this fixed string here. Llewellyn had another way to do it with a date scrubber, which I need to look into because that looked cool as well. So there is some documentation for scrubbers that you can look up, but that's the basic idea. So I wanted to just end. We've got a few minutes left. I've got some more slides really to tell you a bit more about the theory of approval testing. So, oh, I need to make this full screen. So you all know, I'm sure, about unit tests. I've just seen you write a unit test. You know this. A unit is a small piece of code, and an automated unit test will exercise that code, run without intervention, and check that code works or not. And the classic definition of a unit is it could be a method, or it could be a module, or it could be a group of classes. So the size of the unit does vary. And my experience with approval testing is that generally the units are larger than with a classic unit testing approach. Unit tests classically have three parts, which I would call arrange, act, assert. Set it up, exercise it, make claims about what happened. In the approval test, the first two parts are basically the same, but instead of making an assertion, we are checking against the approved version of the output. That is, and that output that we approved previously was gathered from your program. It's not something that I calculated in advance. And that's a difference with the assertion, where the assertion you ideally would have calculated that in advance. But in an approval test, you do not calculate it in advance generally. So then you get this diff tool that shows you the difference between your approved text and your actual output. And here I've got another example with a receipt, but it's the same idea. You can see visually in the diff what's changed between what you get now and what you approved earlier. And then you get to decide, well, is this a bug? Or is this a new feature that I like, behavior that I was expecting that I just want to approve? So this is the crucial step in the approval testing name. It's where you actually decide, do I approve this change or not? It's kind of been glossed over a bit in this particular example, but I put a step between arrange, act, and compare, and that's print. And that's the part where you take whatever your act step produced and make it, lay it out in a good way so that it works with a line-by-line based diff tool, or whatever diff tool you have. So in this case, the act step produced XML, and I don't know if you looked at it ever, but it's just all the XML on one line. And it's really hard to diff like that when everything's on one line and there are no line breaks. So the verify XML method acts like a printer and lays it out nicely, and puts in line breaks to make it easy to do the diff of it. And so in this particular case with the verify XML, the printer was kind of built in. And then there was the scrub step that we might need as well. And that's another part of the kind of the whole print part of the test. You're preparing the output to be ready for the for the line-by-line diff. So print, scrub, compare goes in there. In the more general case, you might want to write your own printer that does something specific for your domain objects that come out of your ACT steps. But in this case, we could use a verify XML. So yes, I just wrote that. The printer formats the XML nicely for us. Scrubbers have some documentation. Now, I would like to put that link into the chat. I will do that shortly when I've exited the slides. And then I just wanted to talk a little more generally and take a step back. Unit tests. There's this kind of saying that it's not a unit test if it uses the file system or a database or the network. And yes, that might be strictly speaking true, but it could still be a very useful test. And I kind of say this because the approval tests, by kind of their very nature, they touch the file system. They are comparing against this approved file. So they are not as fast as your classic unit test. And that might mean you have fewer of them. But in my experience, this thing with them being slow, it doesn't really seem to be a bigger problem as some people think. Maybe because my units are larger, I have fewer tests and it doesn't bother me as much that they're all touching the file system. So that is part of the package with this. And they're still pretty fast. But the main advantage that I would lift up here is the serendipity that you get with approval tests, because here I've got a screenshot of a diff. It's comparing an invoice actually, and on one of the invoices it's got services costing 4,200 krona, and on the other side it's still got services costing that, but there are dancing ponies that have crept in there, and you're just like, I'm glad I had a test for that. But you'd never have written an assert that said assert no dancing ponies. But that's the kind of serendipitous discovery you make with an approval test. That's, oh, look, I've got output I didn't expect there. I never would have written a test that explicitly checked for that, but happily, I have found it. So that's one of the things that I really like about approval testing, that by default, it's checking everything. I'm printing out quite a lot of stuff, and that gives me that serendipity to find unexpected problems. With an assert-based test, you're kind of saying, I'm checking these 3 things. But with this, you're by default checking everything, and then you scrub out the stuff that you don't want instead. So so that's a helpful thing there. So just here, my last slide, basically, further resources about these topics. We've been using the approvals tool. It's not the only approval testing tool out there, but Llewellyn, who's here in the meeting, invented it, and it's a really great tool. I haven't actually put a link to the approval testing tool that my husband invented, but yeah, it works too. It's called Text to Test.
It's also great.
Thank you, Llewellyn. I've got a blog. I've got a new website that I just put up like a week ago called salmoncoaching.org, which describes the kind of coaching I'm doing and what I've just been writing a book about, which you can find on LeanPub. And then there's the 97 things every Java programmer should know, which I have 2 essays in about these topics. So that's basically what I was going to talk about in the slides. So now you've listened to me for a bit. I'm going to open for questions, of course.
There's a question in the chat about needing to update lots of approvals at once.
Oh, yeah. Right. Let me just find the chat. Actually, when I'm showing my screen, it's not obvious how to find the chat. Can you read the question?
Do you want to just ask your question?
It's not mine, but do you ever run into the situation where you need to update dozens or hundreds of approval tests results due to a requirement change?
Of course, yes. That definitely happens. Not only due to requirements change, of course, sometimes it's a bug, and sometimes it's you've changed your printer. You know, so there's lots of reasons you might get a lot of failing tests, and you're pointing out the fact that a lot of tests might be printing something very similar. perhaps using the same printer, they're printing out the same kind of object. And that definitely happens. And you need strategies to handle that. You need tools to help you handle that. And there do exist tools. So the thing is, you need to distinguish between, I have 100 failing tests, but they're all failing for the same reason. I have one problem and I can fix them with one fix. Approve all. And the situation where I have 100 tests failing, but I have 100 problems. And I need to go through every single one and work out what all my problems are. And that is a much more serious situation. And that happens much less frequently. And if it does happen, it probably means you've made at least 100 changes since you last ran the tests. So that's the other thing about approval testing. It really encourages you to run the tests after every change, because otherwise your diffs just pile up. So it really encourages you to work in this agile way.
You want to talk about the tool you wrote for that?
Oh, I could talk about that. Yeah, so it's on my GitHub. It's still a work in progress. Approval tools. Yeah, some useful little Python scripts that will. I've been writing this analyze script that will analyze your failures and tell you if some of them all are failing for the same reason. So that might be worth a look. And there's the approval, which will just approve everything, and clean received, which will get rid of any stray received files that you left lying around. So this is a little thing I've been inventing. But anyway, if you want to go back to the Miro board and write some more notes about what your assessment of approval testing is so far, or if you have any more questions, do you put them up there?
This is frame 6.
Yeah, it's the one at the far right. Oh, I like that question, using scrubbers versus improving the design. Yeah, because using interdependency injection would improve your design, probably. Scrubbers is a way of fixing it for when you don't have that luxury. And that happens with legacy code. Yeah, pairing with a subject matter expert or a PO. Yeah. I mean, these tests really do lend themselves to those kind of BDD style tests that the user can understand. Really recommend that. Really encourages you to make your approved output really readable and really well printed. So there was a question here about whether the approvals are abridged proper unit tests. Proper? What do you mean proper? These are proper unit tests. But you're asking whether we delete them when we've got when we've written some smaller, more pinpointed unit tests. Of course, it's a judgment call. You might do. You might find that they're redundant. On the other hand, you might find that they're testing at a different level, a more like in double loop TDD, where you've got the outer loop, which are kind of more readable, customer facing. You might find the approval tests fall into that role, and it's useful to have them as well as the more pinpointed unit tests.
Have you I'm the questioner, I'm the OP on that question.
Right.
Have you found cases where there's sort of an arc of you inherit this code, you write a bunch of approvals to codify correct behavior, and then you refactor and get more tests in place, and then as the behavior changes over time, you lean more on those and start removing the approvals because they're no longer, their granularity is no longer needed?
I think that does happen. I'm sure people do
Okay.
that, but I really like this approach, and I tend to recycle them or rehabilitate them rather than remove them. And
Cool.
often the smaller level tests are approval tests as well, honestly.
Yeah, I was gonna say, like, I don't usually remove the approval test, but I have things like you mentioned that, like, you would have a proper database where you could get orders, right? So my first test here might be like, let's go to the database and grab orders, because that would get me started. But that test would be horrible and slow and maybe run 10,000 orders, but it lets me get to the place where I could write these unit tests that are actually nice and fast.
Thank you.
Cool. So let's just see if there are any more questions here. Yeah. Would you use approvals in a TDD approach? Oh yes, definitely. I tend to use approvals in any situation where the output of the act step, which is the thing I'm going to then assert on, if that is a number, if it's a float or an int, then maybe I'll just use assert equals. But if it's a string or an object or anything interesting, I want approvals.
Mm-hmm. And the tooling is fast enough to see the result and then say, yeah, this is what I want, and or no, this is not what I want, and change the test there.
Yeah, so
Okay.
I said, they're slow because they touch the file system, but they're not that slow. It's still pretty good.
I mean, also reading a class file touches the file system, right? Like,
Yeah.
The compiler
Cool.
probably also touches the file system.
Yeah. So there's some really nice insights. Test the absence of the unexpected. Concept printing results, scrubbers, judgment call on how many tests to write. Yeah. Cool. So there's lots of nice comments there. And I think we're out of time. So thank you very much for coming. I hope everyone has got something out of this, and I hope I'll see you again around the internets, if not in New Jersey, where I'm not.
Thank you very much, Emily, and thank you everyone for coming and participating, and for your patience with the breakout room function as we set that up. I'm glad that worked out. It was much better that way.
So am I.
Yes, thank you all very much, and stay tuned for the video from this session, minus the breakout room part, and stay tuned for what we'll have next month.
wait. You mentioned a book at the beginning of this, but we didn't hear anything about that.
Oh yeah. Do you want to?
It's on LeanPub.
Okay.
I just wrote a book about technical coaching, which is what I do with the Saman method.
Can I just say, I think somebody named Kent Beck wrote a foreword or a preface or something like that. I'll say that for you.
Thank you. Yeah.
Okay.
Kent wrote the preface.
I think you're trying to tell us that you're better at testing than at marketing.
That might well be true.
Okay, well, I will help with that by posting this video as soon as I can, and sharing it on social media and posting it to the meetup. So that'll be my part, and then you can do some more on top of that. Thank you everyone for coming. I hope you are well and enjoy the rest of your day wherever you are.
Cool.